Classification is the way of arranging the data in different classes in order to give a definite form and a coherent structure to the data collected, facilitating their use in the most systematic and effective manner. Statistical data can be presented in three different ways: textual presentation, graphical presentation, tabular presentation. We will discuss about the classification of data, types or modes of classification, the presentation of data, and tabular presentation of data. Classification is the way of arranging the data in different classes in order to give a definite form and a coherent structure to the data collected, facilitating their use in the most systematic and effective manner. It is the process of grouping the statistical data under various understandable homogeneous groups for the purpose of convenient interpretation. A uniformity of attributes is the basis criterion for classification, and the grouping of data is made according to similarity. Classification becomes necessary when there is diversity in the data collected for meaningful presentation and analysis. However, in respect of homogeneous presentation of data, classification may be unnecessary. The process of arranging the data in groups or classes according to their common characteristics is technically known as classification. Classification is the grouping of related facts into classes. It is the first step in tabulation. In the words of Sechrest, classification is the process of arranging data into sequences and groups according to their common characteristics, or separating them into different but related parts. Cornett defined classification as the process of arranging things in groups or classes according to their resemblances and affinities, and gives expression to the unity of attributes that may subsist among a diversity of individuals. The raw data collected in real situations and arranged haphazardly do not give a clear picture. Thus, to locate similarities and reduce mental strain, we resort to classification. Classification condenses the data by dropping out unnecessary details. It facilitates comparison between different sets of data, clearly showing the different points of agreement and disagreement. It enables us to study the relationship between several characteristics and make further statistical treatment like tabulation, etc. The major objectives of classification of data are: 1. To group heterogeneous data under the homogeneous group of common characteristics. 2. To facilitate similarity of various groups. To facilitate effective comparison. To present complex, haphazard and scattered data into a concise, logical, homogeneous and intelligible form. To maintain clarity and simplicity of complex data. To identify independent and dependent variables and establish their relationship. To establish a cohesive nature of the diverse data for effective and logical analysis, and to make logical and effective quantification. What are the essentials of classification? The classification must be exhaustive so that every unit of the distribution may find a place in one group or another. Classification must conform to the objects of investigation. All the items constituting a group must be homogeneous. Classification should be elastic so that new facts and figures may easily be adjusted. Classification should be stable. If it is not so and is changed for every inquiry, then the data would not fit for an inquiry. The data must not overlap. Each item of the data must be found in one class. What are the primary rules of classification? In quantitative classification, we classify data by assigning arbitrary limits called class limits. The group between any two class limits is termed as class or class interval. The primary rules of classification are: there should not be any ambiguity in the definition of classes. It will eliminate all doubts while including a particular item in a class. All the classes should preferably have equal width or length. Only in some special cases we use classes of unequal width. The class limits should be selected in such a way that no value of the item in the raw data coincides with the value of the limit. The number of classes should preferably be between 10 and 20, that is neither too large nor too small. The classes should be exhaustive, that is each value of the raw data should be included in them. The classes should be mutually exclusive and not overlapping, that is each item of the raw data should fit only in one class. The classification must be suitable for the object of inquiry. The classification should be flexible and items included in each class must be homogeneous. Width of class interval is determined by first fixing the number of class intervals and then dividing the total range by that number. What are the different types or modes of classification? There are 4 types of classification: qualitative, quantitative, temporal and spatial. Qualitative classification: it is done according to attributes or non-measurable characteristics like social status, sex, nationality, occupation, etc. For example, the population of a whole country can be classified into 4 categories as married, unmarried, widowed and divorced. When only one attribute, example sex, is used for classification, it is called a simple classification. When more than one attribute such as deafness, sex and religion are used for classification, it is called manifold classification. Quantitative classification: it is done according to numerical size like weights in kilogram or heights in centimeter. Here we classify the data by assigning arbitrary limits known as class limits. The quantitative phenomenon under study is called a variable. For example, the population of a whole country may be classified according to different variables like age, income, wage, price, etc. Hence, this classification is also called classification by variables. What is a variable? A variable in statistics mean any meaningful or any measurable characteristic or quantity which can assume a range of numerical values within certain limits. Example, income, height, age, weight, wage, price, etc. A variable can be classified as either discrete or continuous. Discrete variables: a variable which can take up only exact values and not any fractional values is called a discrete variable. Number of workmen in a factory, members of a family, students in a class, number of births in a certain year, number of telephone calls in a month are all examples of discrete variable. Continuous variable: a variable which can take up any numerical value within a certain range is called a continuous variable like height, weight, rainfall, temperature, etc. These are all examples of continuous variables. Age of a student in a school is a continuous variable as it can be measured to the nearest fraction of time, that is years, months, days, etc. Temporal classification: it is done according to time. Example, index numbers arranged over a period of time, population of a country for several decades, exports and imports of India for different 5-year plans, etc. Spatial classification: it is done with respect to space or places. Example, production of cereals in quintals in various states, population of a country according to states, etc. Characteristics of an ideal classification: there are no hard and fast rules for making classification of data. Technically, the classification of data depends upon the nature, scope and purpose of study. Nonetheless, an ideal classification possesses some important characteristics. A good classification should have the characteristics of clarity, homogeneity and equality of scale, purposefulness, accuracy, stability, flexibility and unambiguity. Some of the characteristics are given below. Unambiguous means classification of data must be unambiguous. Various classes should be so defined that there is no room for doubt or confusion. 2. Exhaustive and mutually exclusive. Classification should be done in such a manner that each and every item belongs to one and only one class. This implies that different classes should not overlap. Suitability. Classification should conform to the object of inquiry. For example, if an inquiry is conducted to study the economic condition of the workers of an industry at Chennai, it is of no use classifying them on the basis of their caste or religion. Stability. Data are classified generally on the basis of some criterion. Once such criterion is fixed, it should be retained for other related matters. Flexibility. A good classification should be flexible. It should have the capacity to accommodate with a new situation. Stability of classification does not mean rigidity of classes. The term stability is used in a relative sense. No classification can be stable forever. Changes here and there becomes necessary with changes in time and other changed circumstances. An ideal classification should be such that it can adjust itself to these changes and yet retain its stability. Statistical series. Discrete and continuous. Conrad defined statistical series as if two variable quantities can be arranged side by side so that measurable difference in the one corresponds with measurable difference in the other, the result is said to form a statistical series. Statistical series may be either discrete or continuous. Discrete or ungrouped frequency distribution does not condense the data much and is quite cumbersome to grasp and comprehend. It becomes handy if the value of the variable are largely repeated. A discrete variable sometimes may be presented in the form of a continuous frequency distribution when the discrete distribution is too large and unwieldy to handle. What is a frequency distribution? If the value of a variable, example height, weight, etc., which is continuous, the number of students in a class, readings of a taximeter, etc., occurs twice or more in a given series of observation, then the number of occurrences of the value is termed as the frequency of the value. The way of tabulating a pool of data of a variable and their respective frequencies side by side is called frequency distribution of those data. Croxton and Cowden define frequency distribution as a statistical table which shows the sets of all distinct values of a variable arranged in order of magnitude, either individually or in groups with their corresponding frequencies side by side. Let us consider the marks obtained by 100 students of a class in economics. If the raw data of the table are arranged in either ascending or descending order of magnitude, we get a better way of presentation, usually called an array. Now, let us present the above data in the form of a simple, which is ungrouped, frequency distribution using the tally marks. A tally mark is an upward slanted stroke which is put against a value each time it occurs in the raw data. The fifth occurrence of a value is represented by a cross tally mark as shown across the first 4 tally marks. Finally, the tally marks are counted and the total of the tally marks against each value is its frequency. Let us now present the data in table as simple frequency distribution. Now, we will move on to the presentation of data. Statistical data can be presented in three different ways: textual presentation, graphical presentation, and tabular presentation. Textual presentation. This is a descriptive form. The following is an example of such a presentation of data about deaths from industrial diseases in Great Britain between 1935 and 39 and 1940 and 44. Numerical data with regard to industrial diseases and death form. Graphical presentation. Quantitative data may also be presented graphically by using bar charts, pie diagrams, pictographs, line diagrams, etc. The tabular presentation or tabulation. Tabulation may be defined as the systematic presentation of numerical data in rows and columns according to certain characteristics. It expresses the data in concise and attractive form which can be easily understood and used to compare numerical figures. Before drafting a table, you should be sure what you want to show and who will be the reader. The process of placing classified data into tabular form is known as tabulation. A table is a symmetric arrangement of statistical data in rows and columns. Rows are horizontal arrangements, whereas columns are vertical arrangements. It may be simple, double, or complex depending upon the type of classification. Statistical data can be presented in the form of tables and graphs. In the tabular form, the classification of data is made with reference to time or some other variables. The graphs are used as visual form of presentation of data. The tabulation is used for summarization and condensation of data. It aids in analysis of relationships, trends, and other summarization of the given data. The tabulation may be simple or complex. Simple tabulation results in one-way tables which can be used to answer the questions related to one characteristic of the data. The complex tabulation usually results in two-way tables which give information about two interrelated characteristics of the data. Three-way tables which give information about three interrelated characteristics of the data, and still higher order tables which supply information about several interrelated characteristics of the data. Objectives of the tabulation. The main objectives of the tabulation are to carry out investigation, to do comparison, to locate omissions and errors in the data, to use space economically, to study the trend, to simplify data, to use it as future reference. There are different types of tabulation. Simple tabulation or one-way tabulation. When the data are tabulated to one characteristic, it is said to be simple tabulation or one-way tabulation. There is an example of one-way tabulation of data. Double tabulation or two-way tabulation. When the data are tabulated according to two characteristics at a time, it is said to be double tabulation or two-way tabulation. Example, tabulation of data on population of world classified by two characteristics like religion and sex is example of double tabulation. Complex tabulation. When the data are tabulated according to many characteristics, it is said to be complex tabulation. Example, tabulation of data on population of world classified by two characteristics like religion, sex, and literacy rate is an example of complex tabulation. What are the characteristics of tabulation? Every table should have a clear and concise title to make it understandable without reference to the text. This title should always be just above the body of the table. Every table should be given a distinct number to facilitate easy reference. Every table should have captions, that is column headings, and stubs, that is row headings, and they should be clear and brief. The units of measurements used must always be indicated. Source or sources from where the data in the table have been obtained must be indicated at the bottom of the table. Explanatory footnotes, if any, concerning the table should be given beneath the table along with the reference symbol. The columns in the tables may be numbered to facilitate reference. Abbreviations should be used to the minimum possible extent. Tables should be logical, clear, accurate, and as simple as possible. The arrangement of the data categories in a table may be chronological, geographical, alphabetical, or according to magnitude to facilitate comparison. Finally, the table must suit the needs and requirements of the research study. An ideal statistical table should contain the following items: table number, title, date, stubs or row designation, column headings or captions, body of the table, unit of measurement, and sources, footnotes and references. A table should be logical, well balanced in length and breadth, and the comparable columns should be placed side by side. Light, heavy or thick or double rulings may be used to distinguish the sub-columns, main columns and total. For large data, more than one table may be used. The advantages of a tabular presentation over the textual presentation are: it is concise, there is no repetition of explanatory matter, comparisons can be made easily, important features can be highlighted, and errors in the data can be detected.